numbers. So you might remember last lesson we talked about imaginary numbers. So an imaginary number is a number that is composed of imaginary parts. So what is I? I is the square root of -1. Alright? So we have real numbers, which are just numbers that can fit on a number line. We have imaginary numbers, which are composed of the square root of -1. And now we're going to introduce you to what's called complex numbers. And they are a number that has a real part and an imaginary part. Okay, so they've got a real part and an imaginary part. So that's what we call a complex number. So in this complex number, the real part of it will be 3 and the imaginary component is -4. In this complex number, the real part of it is -1 and the imaginary part is +1. The coefficient is called I. So if we're going to say what's the real part of W, well the real number over here is -1. The imaginary part of Z here is -4. If we are going to add complex numbers together, we add the real parts together and we add the imaginary parts together. So it's going to look like this if we write it out. Then it's going to be 3 take 4i plus -1 plus I. Alright? And then we're going along and just collecting like terms. The real components are like terms, so we can add them together. 3 take 1 is 2, and -4i plus I is -3i. So when we have complex number Z plus the complex number W, the result of the complex number is 2 take 3i. Okay, 5ZW means 5 times Z times W. Welcome, come on in. Did you go to Gillett-Wonga?
Yeah.
Sorry. We're in here for the next 2 weeks. Wow. So we're going to have 5 times the complex number Z, which is 3 take 4i, times the complex number W, which is -1 plus I. And then we're just going to FOIL that and simplify it accordingly. So I'm going to leave the 5 out the front for now. We'll multiply that through after, and I'm just going to do some FOIL here. So 3 times -1 is -3. We have 3 times I is +3i. -4i times -1 is +4i. And -4i times +I is -4i squared. Okay, now over here I've got I squared, right? What is I? I is the square root of -1. So if we have I squared, that's the square root of -1 squared, which is -1. So I squared is, I is an imaginary number, and when we square it, it makes it a real number, makes it a real -1. So here this becomes, I'm going to simplify all these, we've got 5 times -3. 3 plus 4i is 7i, isn't it? We've got 3 lots of I plus 4 lots of I, 7i. And here I've just said I squared is -1. So you'll be able to do these pretty quickly, but I'm just going to do it over a number of steps just to point out that I squared goes to -1. Now we can perform that multiplication. We've got 5 times -3 plus 7i plus 4. We can add these parts together, the -3 and the 4. That's going to be +1. And then we can distribute the 5. Alright, so just some algebra that we learned in Year 9, but with some new ideas to it, imaginary numbers, okay? So we did the FOIL, I squared goes to -1, we're just collecting like terms. Excellent. Let's move on to E, where we have the real part of Z on W plus 3. So that means what we're going to need to do is we need to find first the complex number Z on W in simplest form. So if I have Z, let's just think about this part of it first, Z on W. Let's ignore the rest, let's just localize this part of it. We're going to have 3 take 4i on top of -1 plus I. So if we want to write this as a single complex number, can anyone remember how we did it with surds? What did we do with surds to get rid of that sort of denominator? We multiply it by the conjugate. Okay, so the conjugate of the denominator is minus 1 take I on minus 1 take I. So we're not changing the value of it in any way. But what that's going to allow us to do is write this expression with a real denominator. Alright? Because let's have a look, I'll write out what's going on at the top. We've got 3 take 4i times minus 1 take I. So that's just going to be some FOIL up the top. And in fact, we've already done that FOIL, so I can just grab it from over there. And at the bottom, we've got minus 1 plus I times minus 1 take I. This is difference of two squares, isn't it? It's a plus b times a take b, which is a squared take b squared. So at the bottom, we're going to have minus 1 squared take I squared. Okay, so this FOIL, I'm not going to repeat it. I've done this exact expansion. No, it's a little bit different because the I is negative, isn't it? It's a little bit different, so I will do it. We'll do it. Okay, so we're going to have 3 times minus 1 is minus 3. 3 times minus I is minus 3i. Minus 4i times minus 1 is plus 4i. And minus 4i times minus I is positive 4i squared. Okay, so that's just some FOIL at the top. And at the bottom, I've got minus 1 squared, which is positive 1. Take away I squared. What is I squared? Minus 1. Okay, I squared is always minus 1. So at the bottom we have 1 take minus 1. Okay, let's collect the like terms at the top. We're going to have minus 3. This is going to be plus I. So we have minus 3 lots of I plus 4 lots of I. It's plus 1 lot of I. We have plus 4i squared. Well, what is I squared? It's minus 1. So we have 4 times minus 1. That's minus 4. Okay? And at the bottom we've got 1 take minus 1. That's 2. Alright, come down here. So minus 3 take 4 is minus 7 on 2 plus I on 2. Okay? Or you can think about it as half I. Okay, so the complex number z divided by w is this number here. That's what it simplifies to. All right. Now let's answer the question. What are we asked for? We're asked, what is the real part of z on w plus 3? Well, the real part of z on w, the part without the imaginary number, is minus 7 on 2. Okay, so let's write that here. The real part of z on w plus 3 is minus 7 on 2 plus 3, which is minus half. Okay, so it's just some operations, recognising what's the real component, what's the imaginary component, and then smashing some operations around with them. So that's 7F1. I did write down to do both 7F1 and F2 today, so we'll see how we're tracking along. I think you'll find this not too badly. All right, let's do it.